Hello everyone, welcome once again to my YouTube channel. Happy New Year. This is my first video for the year 2025. You are welcome once again to my YouTube channel. So today we're going to be looking at machine learning. Yeah, is somebody excited? Okay, so what is machine learning? I'm not here to give you Google's definition of machine learning. I'm here to give you a definition that you understand. A layman can understand what machine learning is all about. Now, first and foremost, we need to know that machine learning is a subset of artificial intelligence. So we've been hearing AI, artificial intelligence. Machine learning is a subset of artificial intelligence. Now, what is artificial intelligence? Most of the time you see robots behaving like human, you see robots in factories carrying things. They are doing the tasks a human being can do. They are able to do that task because they've been programmed to be able to do it. They've been fed data to be able to do that. So now what is machine learning? Machine learning is the process of, or a way of teaching the computer, how to predict. Now this is how it happens. You have a computer system, you feed it with data. Now what is this data? Data is past information, past experiences. You are feeding it with past experiences so that it can learn from those past experiences. For example, a child is just born into this world. It doesn't know anything. But once it goes near fire and it touches fire for the first time, next time when it's going close to something that is very, very hot, it might not necessarily be fire, but something that is very, very hot, he knows that he's to be very, very careful. Don't just go straight and touch, because there's the possibility of getting burnt. So machine learning involves feeding the computer with data. When you feed it with data, it analyzes that data so that it can be able to establish patterns in that data. So once it's able to establish patterns in the data, what happens? With that information it has gotten now, it can be able to predict, okay, this is what is going to happen. For example, let's talk about customer retention. In a small business or a business that involves buying and selling of products or goods and services, you have information of your customer, what a customer has bought. Let's say last year, the things he bought, last 2 years, what the customer bought, last 3 years, what you have all this data. Now you feed it to the computer. So for example, let's say we're talking about dress now, okay? And the customer, I love flare gowns, flare skirts, flare top. And that is what I've been coming to buy from your shop for the past 3 years. So with this information, once you feed the computer with this information, it uses statistical model or statistical formulas to be able to look for patterns in this data set. So it can say, it noticed flare skirt, flare gown, flare this. Then it says, okay, it's like this customer loves flare apparel, whether it's a flare top, whether it's a flare gown or a flare whatsoever. Then next time when the customer comes, you'll be advertising flare clothes that has flare in them, whether a flare hand. And once you are advertising what a customer already likes, the possibility of the customer buying that thing from you is higher. So that is what machine learning is about. I will explain again. Machine learning involves taking data, past data, putting it into a computer system, then using statistical models or formulas to look for patterns in this model, in this data set. Once it can establish this pattern, it can now predict what will happen in future or what is a customer will always want to buy. So this is just the basics of machine learning. So now in this video, we'll be looking in details how to work with machine learning as a data set, to predict a data set, to work on a data set using machine learning, that is using statistical models. So you'll be able to see how we are able to predict things with the data with the statistical model. That is machine learning. You cannot separate statistical model from machine learning. So stay with me as you see me explore the data. I'll explain the data set in details, what the data set is all about. Okay, now the data set we're going to be using for this video or for this tutorial is a data set of pack visits. That is, the problem is the pack. The organization manages several packs. Now, some of the packages in the packs are swimming, hiking, playground, and so on. Now, what happened was that in 2023, there was a sudden surge in customers. So by 2024, the number of customers that came were overwhelming. So the organization wants to see how they can predict the possible number of visitors that will be coming next year, so that they can be able to prepare for these visitors when they are coming. So for example, we have the restroom. If usually you have between 500 to 1,000 visitors that come per year, you have been preparing for about 1,000 visitors, so you have toiletries for 1,000 visitors. But when you're able to predict, okay, maybe next year now, based on advertisements, having new pack features, and so many other details, if these things are in place, then we should be expecting maybe 2,000 visitors. So as the park management, you know, okay, now for the toiletries we are budgeting for 2,000 visitors. So this makes the park management to be able to effectively manage the park. So this is one advantage of machine learning, and this is the project we'll be looking at as we go through this tutorial. So sit back, relax, and enjoy.
Machine learning, it's divided into two major parts. That is, it's either you are dealing with a classification problem or you are dealing with a regression problem. Now, what is classification problem and what is a regression problem? That is always where you will start from anytime you want to do machine learning. Now, our data set, which we need to understand first. Now, we have the feature columns, which is every other column except this column, M column, that is the pack visit count column. The pack visit count column is the target column, or you can call it the dependent variable column. Now, this pack visit column, which is the dependent variable column, or you call it the target column, is depending on the other features, which we call the independent variables. It depends on these other features to know the number of visitors that will come per day. So, advertisement can determine, we can see the advert here. This is the advert column. So, advertisement has influence on the total number of visitors. Now, we have the pack features, that is special pack features. For example, maybe a new pack feature was put in place, maybe a new swing for children or something new. It can also attract more people to come. Then, is it weekend or not? And is it school vacation or not? Then this is the weather condition, the wind speed, humidity. Humidity determines heat. Precipitation, that is rainfall. Temperature, high or low. If it's too low, we know that it's cold will be too much. And if it's too high, terrible heat. Then holiday indicator. Then day of the week. So these are the features that determine the number of people that will come to the park. So if it is weekend, we are supposed to expect more people to come. If it is holiday, we should expect more people to come compared to when there is no holiday. Then if the temperature is okay, it is not too low, we should expect more people to come. Even though the temperature is high, people can still come for something like swimming. Then rainfall will affect people coming. Then weather condition, is it rainy, is it cloudy? It also affects people coming. Is it a weekend? Is school on vacation? If school is on vacation, then that will, at least if we check that, we can know that, okay, we will expect more children coming in combination with if it is a holiday and the temperature is okay. Then sometimes advertisement too. You can advertise your business, the park. Oh, these features are here, and somebody might be seeing it for the first time, and we decide to come. Then we have special park features, any new features. So on this day, January 1st, they didn't add any special park features. There was no advertisement. School was not on vacation. It was not a weekend. The weather was cloudy, and so on and so forth. Now, on that day, we had 70 visitors on the 1st of January 2020. So now this is the data set. Now, what is the problem? The problem is we want to know the number of visitors that will come in subsequent years so that the park can be able to prepare for such. So if there's going to be a surge, then we know, okay, we are going to put so and so things in place to mitigate any problem that can arise by overcrowding, because of overcrowding. So from this, if you look at this park visit count, now, how do you know a problem is a classification problem or a regression problem? A regression problem, when you are dealing with a regression problem, you are dealing with continuous information, a continuous variable. What do I mean by that? We want to get the total number of visitors that will come in subsequent years. We are not grouping it. It can be 1, it can be 10, it can be 20, it can be 1,000, it can be 1 million, it can be, the list is endless. So that makes it a regression problem. But if it is a classification problem, then it can come like this. Okay, we want to know the level of level of crowd that will come in subsequent years. Now, the English might not be so perfect, but I hope you understand me. Now, what do I mean? Like this problem now, this data set, we can run it as a regression problem or a classification problem. For now, this park visit count column is in a regression form. That is, the list is endless. But if we want to make it a classification problem, then we can do this. We can say count from 0 to 500 is low crowd or low number of visitor. From 501 to 1,000 is medium number of visitors. From 1,000 and above is large number of visitors. Obviously, we can choose to create an extra column for that and automatically make that our target column. Then we can drop this park visit count column if we want to run it as a classification problem. So one thing about classification problem is dealing with finite, that is not dealing with infinite number of variables. It's dealing with a finite number of variables. So the grouping is obvious. You can see it, you know it, you can understand. These are the groups so we are looking at. We want to see if it is large, medium, or low number of visitors. But you know, that is a little bit restrictive. So it's better to run it as a regression problem. So it will give you an explicit number of visitors. So you can know, okay, per day, these are the numbers of visitors, instead of grouping it and saying from 0 to 100 is low. So for example, in the month of February, each day can be in that group of 0 to 100. So you cannot know the number of visitors that you had per day. It will be difficult. But with regression, you can know, okay, in the month of February, this is the number of visitors I had on the 1st, on the 2nd, on the 3rd, and so on. So regression makes it more explicit. So for me, I will stick to running this problem as a regression problem. So I will repeat myself. The difference between a regression problem and a classification problem is a regression problem, the target variable, which is this visitors count variable, which is the problem, contains infinite variables. It's not grouped. It's infinite. But in classification problem, the grouping is obvious. So you can know, okay, is it high, low, medium? Or are we trying to classify this problem to know if, for example, if we are dealing with animal now, and the data sets we have are maybe skin color, shape of the body, tone, voice, words. Okay, with all this information, I want to know, is this a dog? Is this a cat? Is this a human? For example, if from the audio, which is part of the data set, we are hearing woof, woof, then the shape is, you have a picture of a dog, different types of dogs. So the machine learning algorithm will run for, obviously you'll be using classification. It will run, check all the features and check, okay, it will now group it and say, this is a dog. Or if it hears meow and other things, this is a cat. The reason why we will not work with only meow is because maybe a human, for example, you can hear now I'm saying meow. So the audio is not enough to prove this is a cat. We also need the structure, that is the shape, and so many other things. So that is how machine learning start. That is where machine learning starts from. First, what is the problem? The problem in this case is we want to know the total number of visitors. Okay, so that means it is infinite. So we go for regression. 2, you understand what your data set is all about, what each feature is contributing to the target column. We know pandas, NumPy, yes. Now, the library that is most commonly used for machine learning problem, most commonly used, is not exhaustive, there are so many, is Scikit-Learn. That is Skit, S-K-I-T, then learn. This is it. So that's what I'm using now. Okay, so I've imported my libraries. Let me run it. Then we'll be working with this library, XGBoost. This is a advanced machine learning. But for now, we're going to keep it on. First and foremost, Scikit-Learn model selection. All the machine learning is very wide, but let's start with the basics. Now, these are the libraries I'm using for this data set. And as I proceed, we'll understand better. Now, what is this train test split for? This train test split function, which is in this Scikit-Learn model selection library, splits your data set into train and test data sets. Now, let me explain. In machine learning, like this problem now, we are predicting the number of visitors we have in subsequent years. And after predicting, we will need to test whether our prediction is correct. So that is where train test split comes into place. This train test split, the work of train test split is to split your data set into two parts. Let me go directly to the line of code that does that so that you will understand better. Okay, this is it here. So what does it do? It splits the data sets into this test size now is 0.2. That is, you have your old data set. 20% of the data set should be kept aside to test our model if it is correct. Now, what does this do? It will check after using the 80% of the data, which is the train data, to train the model. Okay, let's use animal as I used before. For example, we have characteristics of dog and cats. And let me add human, because the human aspect is what we confuse everything, because a human can bark like a dog and meow like a cat. Okay. So with all the available features, we have informations, we'll divide those information. 20% of those information, we'll keep it. 80% of those information, we'll use it to train the model. We'll put it into the model like this place now. This fits into multiple models. This place now, this fits into multiple model. Then here, this line of code, fit X train, Y train is what is used to train the model. That line of code is what is training the model. So now you'll be asking, what is X and what is Y? Your X variable stands for your features, while your Y variable stands for the target variable. So this Y will contain the information on pack visit count, while the X contains every other information on your data set. Then this test size is saying, keep 20% for testing the model. Then random state, 42. You can put any number, it must not be 42. This random state, what it means is, for your model to be more accurate, it is advisable you shuffle it. So what this random state does, it shuffles your data set, mix it, just like shaking it before you tell people, okay, oh yeah, you should come and pick. You understand? If you want to do raffle draw now, to make it equal and fair, what do? They will rotate the something, shake it, so that at least you know, okay, there's no manipulation here. Oh, everybody pick. So that is the way it goes. So this random state shuffles the data set 42 times, then presents it out, and then you can now work with the data set. So that is how it works. Your X train will contain 80% of the variables in X, while X text will contain the remaining 20% to test it. Your Y train will contain 80% of the pack visit count. That is all those numbers there to take 80% of the data. That is, you count 8. Let's assume we have 100 rows of data there now. It will count 1 to 80. Pack all those information and put it on Y train. Then the remaining 20% to put it on Y test.